This video is going to be about costs at firms. Right? Firms can't produce things for free, and if they want to profit maximize, as we'll see later, they have to figure out how much their output's going to be in the face of a price that they can charge for their good or service, and that'll enable them to maximize profit. So here what we're trying to do is just know a little bit about the costs that firms have to undertake in order to produce something. So for us, there's going to be a couple of important ideas that we have to understand before we can get to these numbers here. First off, there's a fixed cost. And I have that represented by FC in this column here. But fixed costs are costs that don't change with output. So in other words, once I know what fixed costs are for a firm, I've figured out that value from 0 up to 1 million units produced. Fixed costs are things like rent, utility installation, things that once you have paid that cost, you can take the month off and not produce anything, and you still have to incur that cost, or you can work the entire month and that cost isn't going to change. Then the other costs that firms face, are variable costs. Variable costs, as the name suggests, are costs that increase with output. So anytime you're talking about variable costs in this class, we're really talking about hiring workers, because in order to produce more goods, the firm has to hire workers, which means they'll have larger labor costs associated with production. So for fixed costs, right, we're really thinking about the capital the firm works with. Once it's decided on capital levels, it's in the short run, and the only way that it can change its total productivity is to hire workers, which is going to increase variable costs. Together, variable costs and fixed costs equal total costs. So once I have fixed costs and variable costs, I can move on and calculate total cost. So let's look at this firm here. We've got 5 different levels of output, and we've got some information about the variable costs the firms face in order to produce these 5 levels of output. And we also have some information about fixed costs here. And I want to fill out the rest of this table so that we can have an understanding about how these variables can be calculated. All right, so let's start here with fixed costs, right? When no one shows up to work, the firm still has to pay $50. That's probably for rent or utility hookups or some other fixed costs that they must pay in order to be in business. But once I've figured out what fixed costs are, I can fill that in for the rest of the output variables up to infinity, right? Because fixed costs don't change. Now I've got variable costs here in this column, and variable costs you can think of as wages that have to be paid to workers, or they also might be payments made to suppliers of inputs, right? The more that I produce, the more I'm going to have to pay suppliers who supply me the inputs needed for this production process. So at output equal 1, the variable cost is 20, the fixed cost is 50, and so I can figure out what total cost is by just summing those two variables. Right? Same thing here. Total cost is 82 because the sum of 50 and 32 is 82. When 3 units are produced, total cost is 92. When 4 units are produced, total cost is 104. Okay, so now I want to move over to the averages. Right, and a fact that we have to understand here, average fixed cost, which is fixed cost over output, average fixed cost is going to move towards 0 as output approaches infinity. So I'm not really interested in calculating average fixed cost here, but what I want to show, what I want you to understand is that eventually, as output starts to grow, average fixed costs move towards 0. That has to be the case because I'm dividing a non-changing number by an ever-increasing number here. So average fixed cost is always going to tend towards 0 as I produce more. The business term for this is smoothing overhead. So if we think about the overhead that some firms face, right, and we could think of the overhead for maybe Facebook, right? Facebook's overhead was getting that computer code established so that that web program could handle massive amounts of traffic from people using their program. That's a fixed cost. Once that's done, that doesn't have to be updated, and the average fixed cost starts to plummet towards 0 as the number of users of Facebook, right, has approached probably well over 1 billion people by now. So that's definitely a company that smoothed its overhead. They were able to figure out, they had to go through the rigorous fixed costs of figuring out an algorithm to produce that web page. But once that's done, as more and more people start to use it, average fixed cost gets really, really small. Now, average variable cost is just variable cost over output. So I'm going to take the variable cost amounts and divide them by output. Right, and this is just kind of thinking about the costs associated with production for each good smoothed over the output levels. So I can't calculate average variable cost when the firm doesn't produce anything. I can't divide by 0. But when they produce one good, right, the average variable cost is 20. When they produce 2 goods, the average variable cost is 16. When they produce 3 goods, the average variable cost is 14. And when they produce 4 goods, the average variable cost bumps up to 14.5. Then I've got average total cost. Right? Average total cost is just total cost divided by output. Another way I can think about this is it's variable cost plus fixed cost in the numerator divided by output. Right? And with average total cost, when I produce no goods, I can't calculate that. And then when I produce one good, average total cost is 70. I just divide 70 by 1. Average total cost when I produce 2 goods is 41. Average total cost when I produce 3 goods is 30.67. And average total cost when I produce 4 goods is 26. And then finally we have marginal cost. Marginal cost is the change in total cost given change in output equal to 1. All right, so in our class, margin means one more. I've produced one more good. I want to know how total cost changes given that change in production of equal to 1. Okay, so marginal cost when 0 goods are made, that can't be calculated. When the marginal cost of producing the first good, right, the total cost of producing 0 goods was 50. The total cost of producing 1 good is 70, so I can just subtract those two values and get a marginal cost of 20. When I produce 2 goods, right, I've got a total cost of 82. The total cost of producing 1 good was 70, so marginal cost is 12. Then the total cost of producing 3 goods, the marginal cost has changed by 10 there. And then the 4th good produced, the marginal cost of that 4th good is 12. So you can see here, marginal cost starts high, it starts to fall, and then it reaches this minimum here, and this minimum, right, we want to connect that, that's where diminishing marginal returns to labor sets in. This is where the firm is most efficient. It doesn't necessarily mean it wants to stop producing at 3 goods. What it means is that if the firm starts to produce past that point, it's going to have to reconcile those fixed cost constraints that we talked about in productivity. So those two ideas are very much linked together here. When the firm reaches the maximum efficiency with the amount of labor that it hires, when diminishing return sets in, when marginal product of labor is maximized, that's also where marginal cost is minimized. Okay, so let's graph these values now that we've calculated them. when we're graphing these, this is the dependent variable here. This is the independent variable, rather, because we're choosing the output level, and then the cost is the dependent variable dependent upon what our output level is. So when I'm graphing these things, I like to think of marginal cost first. Marginal cost we're always just going to think of as a J-shaped function. And then average total cost, right? Just like in the world of productivity, average total cost is going to fall until it reaches marginal cost, and then it's going to start to rise. So it takes on that saucer shape, reaches its minimum when it equals marginal cost, and then average variable cost falls until it is equal to marginal cost, same as average total cost, and then it starts to rise after that. Now, one thing I can do with this is I can calculate geometrically what the total cost, variable costs, and fixed costs are given some output level. So I'm going to choose a random output level. Let's just call it Q star. And given the fact that I have an output level, I can figure out the geometric representation of total cost, fixed cost, and variable cost. All right, total cost I know is average total cost multiplied by output. And I have output, right? Output is this horizontal distance from the axis over to Q star. And I've got average total cost, right? Average total cost of producing Q star goods is the vertical distance from the quantity axis up to the average total cost curve. So I'm going to draw a rectangle, and I'm going to say it has vertices A, B, C, D. Right? And the area of that rectangle equals total cost, because output multiplied by average total cost ends up giving me total cost. Okay, so I can do the same thing with variable cost. Variable cost I know is average variable cost multiplied by output, and I'm going to just do the same thing here. I've got the horizontal distance from D to C, that equals my output level, and then I draw a vertical line up to the average variable cost curve, and I'm going to label these points E and F. So EFCD is the variable cost of producing Q star goods. And then remember, the difference between total cost and variable cost is fixed cost. So it has to be that this rectangle ABFE is fixed cost. So I've got three different rectangles that are showing me what total cost is. That's A, B, C, D. I've got variable cost at EFCD, and then I've got fixed cost at ABFE. And the last thing that we want to be aware of here is this relationship between average total cost and average variable cost. Remember, this distance B to F equals average fixed cost, given Q equals Q star. So that vertical distance between the average total cost and average variable cost curve is average fixed cost. And notice that distance starts to fall as output increases. That should make perfect sense, right? Average fixed cost approaches 0 as output approaches infinity. And our graph here shows that actuality at really low output levels. Average fixed cost is large, and then as I produce more and more, average fixed cost gets really, really small. That vertical distance between the average total cost and average variable cost curves is nearing 0.